Welcome back to Josh Does Math. This video we're going to be finding the derivative of this function right here. So this function is a quotient, so you might be thinking, well, let's use the quotient rule right off the bat. But take a step back and look at what this function is. You could take the derivative of this function a lot easier than the quotient that I wrote up there. And this function down here is exactly the same. I just wrote the exponent a little differently so that it's no longer a quotient. Instead, I use a negative exponent. So looking at this negative exponent, you can clearly see, oh, I just used the chain rule and I'm done. And that's exactly right. So you just cut out the quotient rule, which, okay, no one really cares that you cut it out, but that's a lot less chance of error because the quotient rule is probably the most complicated of the derivative rules that we know so far. So by cutting out the quotient rule, there's just more of a chance that you're not going to make any mistakes. So we're going to use the constant multiple rule first to pull that 6 out front. Then we're going to be using the chain rule to pull the negative 3 out front. And then we're going to say 1 smaller on the power times the derivative of the inside, which is negative 4. And now I just combine my constants here, so I get ds dt is equal to, that's going to be a positive 72 all over 5 minus 4t. And I'm just moving that back down into the denominator because I don't want to write a negative exponent up there. And that's the derivative right there. So sometimes it pays to do a little bit of algebra before you do your derivatives because it can just make your life a lot easier whenever you actually go to take the derivative. Thanks for watching.